Alright, hello, hello, hello. Hope you're having a fantastic day. I was on time, however, sometimes OBS decides that it's not going to show my camera, so I had to spend 10 minutes changing the camera, restarting OBS multiple times, doing random stuff, just so you can see my lovely face. Well, yesterday, when we finished up, we had, I guess I will just launch this. We had basically what's a hulling or a hull algorithm set up using surface nets. So these are this is our scalar field. Technically not voxels because we're not actually using ray marching, but I'm not really that pedantic. I think it's easier just to call them voxels. I mean, they're volumetric pixels, right? That's what it means. So these are 3D cubes. I mean 3D pixels. I would say those are still voxels. Anyway, even though they're rasterized. Pixels are rasterized after all, so yeah, as you can see, we've got a pretty nice hull going on here. This is interesting. Oh, yep, it's got a backwards staircase pattern there. That's all good. So the next step I was going to do was I was going to make multiple chunks. So I started making this chunk load function last night, but I didn't really get much time. So that's one thing we could do, but actually I think I want to work through the rest of the surface nets and see if we can get these to look a little bit smoother. So the next step is we have to relax the surface nets. So let me find that tutorial we were using. It was a Medium article. It's the first result by Ryan Remmer. Or Reema? Probably Remmer. Reema sounds a little bit weird. I think it would be Remmer, right? Regardless. So, basically we're up to this point here. We have found our surface points, which we've done. So this one, okay, the mesh, we need an indexing system to identify all the sample points and all the surface points and how they relate to each other. Do we? Each sample point will have its ID assigned based on its position. Vector 3i0 for position 0, 0, 0. You can assign the ISDs to be the same ID as the sample point in the minimum corner of the sample that they're inside of. Okay. I don't really think we need to do that, but maybe there's a good reason for it. Let's see. Creating quads. So we've already done that part. So add reverse quad, get quad points. Okay. We should have something that looks like this. Yes, this is what we've got, basically. Now, next step is to implement better surface points. There are many ways to move the surface points closer to the surface of the sign distance function. This is the way I found works best for most shapes. Check each of the edges of the sample voxel. If an edge has points with different signs, then find a point along that edge closest to 0. Calculate the average of all these edge points as our sample point. Wait, what? So there's an edge. Okay, an edge is just 2 points. And if they have different signs, find the point along the edge closest to 0. Okay, that's just a linear interpolation between 2 points, depending on the noise value. So the average of all the edge points. Oh, I see. Wait, what? Where is that? Total divided by surface edge count. Get surface position. Alright, for edge offsets in edges. Sample A, position B, sample B. If they're less than or equal to... Oh, that's a clever way. If they're... Okay, multiply them together, and if that value is less than 0, less than or equal to 0, then there must be different signs. Because a negative number multiplied by a negative number is always positive. Ah, that's smart. That's what I should have done. Let's go down here. I will make that change right now. Although I don't think it really matters. Actually, it's just clever. Where is our stuff? Oh, it's way past here, past here. It's above this though. Hang on a second. What? We've got the descriptor sets. Here it is. Alright, so here's our surface nets geometry. So basically, instead of this, it could just be phi times nx is less than or equal to 0. Yeah, that does look nicer, but it's not a huge deal right now. Okay, so I don't quite understand why he says calculate the average of all the edge points. So each edge... Oh, I see. So each edge related to a single voxel. Okay. So let's have a look. I'm going to open up the thing. So if we look at, for example, this one's sticking down here. Hello, Super Gem. Asking me, do I know anything about collision detection on mesh terrain? Do you use something like bounding volume hierarchy? I haven't done a lot of mesh terrain collision, but BVH would work, yes. I think that would be totally fine. I assume, well, it depends on what kind of terrain you're building, but since my one's going to be pretty smooth, I will probably use something like a BBH, and I guess maybe GJK, which is a pretty standard algorithm for collision detection. I've implemented it once before, just because the triangles will all be different sizes and stuff. But if it was just cubes, if it's cubes, then you could use something way simpler. You could just literally get the surrounding cube values around you and just do it on the fly, probably. But yeah, since we're going to generate a mesh, I think that's a good starting point. BVH is good. There are other acceleration structures that I don't know that much about. Let's see. So back to the point here. So we've got these edges. So there's one edge here between the green and the purple, right? There's one edge here between the blue and the purple. There's one edge here between the red and the purple. And also along the top there between the blue and the blue. And I guess between that blue and etc. So what you would do is you would relax those points, average them out. But does that mean, what does that mean? Okay. So count the edges, add them together, and linearly interpolate between the values. If it's 0, then you just return the center point. Okay. Actually, what is this? Vector 3 index plus vector 3 1 times 0.5. Isn't that just 0.5? Oh, this doesn't have vector math, whatever language this is. Right, so, and then you divide the total by the surface edge count. But what is this total? It's a vector. Oh, that's interesting. I think maybe the code is just weird. So you could probably just multiply this by 0.5 because you can do a divide by a scalar value, so you should be able to do a multiply, right? Anyway, these are the edges here. So this is what this is referring to. Okay, gotcha. Alright, so you just got a static array of edges to iterate through for this. That makes sense. We could do the same thing. Let's give it a try. I'll just make the edges here. I will actually make it a non-constant because you can't iterate through a constant array in Odin unless you make it another variable. Let's take a slice of it or something. Oh, I got some acid reflux. It's not good. All right. What are you making with Super Gem? What kind of game are you making? So 1 fact 3 eyes, yeah. I guess we go. So these are edges. So an edge is 2 points. I don't know what they consider to be an edge because. Oh, are they talking about something like a It's called a unit, not a unit cube. It's called a. Maybe it is a unit cube. When you do marching cubes, you take 8 voxels and then you use that as one set to compare against. I think that's kind of what they're doing here. So we would go 0, 1, 0, 0. Actually, I'll write out the 0, 0, 0 so it's clear. Okay, so that's one edge, I guess. So the first voxel to the one just to the right on the x-axis. Actually, I can probably just copy this, save myself some time here. Copy, thank you. Okay, so we're gonna grab this. Good. Now, sometimes when I copy stuff like this, it comes back to bite me. Wait, edges on max Z axis. Right, that would be these ones. Min Z to max Z. Okay. What's the problem with this? Expected 3. Oh yeah, right. So this needs to be slice of 2. Back 3 eyes. There we go. Alright, so we've got the edges. Okay. Well, I guess I'll just try to implement the rest of this as they have it. So. Oh, I added some timings here to see how long this stuff is taking, and it's taking like 2 microseconds or something for one chunk, so that's really good. Yeah, I'll do edge relaxation or something. So we're gonna say total is a vec3. Surface edge count is 0. Okay. The way that they've done this is a bit weird. So it's vector3 index, which is a vector3 I. Oh, okay, so this the casting of to a vec3 I. I see. Okay. We can't do it like that though. We have to do it a bit differently. I actually think there is a much better way to cast something. I saw it, someone posted it in the Odin chat. This function I didn't know existed. 2F32. So you can actually do, yeah, you can actually do what they did up there. Actually, I'll just put this on a new line, 2F32. And then the index, which we don't have. I guess I'll make this into a function. Why not? I prefer calling it coordinates rather than index. Yeah, we don't have edges in here. Let's get that in there. So, I don't really understand this function yet, so I'm going to implement it so I can see how it works and then get a better understanding. Damn, this acid reflux is killing me. Oof. I need to eat more protein. Okay, edge offsets. Gotcha. So this is okay, I see. Plus edge offsets 0, which would be the first part of the edge. It's declared but not used. I need to update my Helix version actually. WinGet. Yeah, I'll do it soon because then I can get better inline diagnostics, which would be nice, but that's all right. Sample A. Oh, I see. Get sample value. Didn't we already do all of that? I guess they functionalize it. They put it into a function. So I think this would just be a lookup for us, rather than get sample value. So this would just be, where is it? Sample field, index from chord, something like this. Okay, and then we got x, y, and z plus 1, no. Chords. Oh, not chords, actually, PA. This doesn't exist in the scope. I'll have to pass it in, because this is a function. So pass in the sample field, which is F32s, right? Okay, what's the problem with this? I'm trying to add F32s to integers. Oh. Yeah, of course. There we go. Now, the problem is... oh, that's kind of the problem. I'm going to call it CA for coordinates. Maybe I'll actually just call it coords A, sample A. Okay, coords B. Sample B, there we go. Now, we'll turn them into vec3s, I suppose. Actually, I could do that. Two F32, coords A. If PA times PB is less than or equal to 0, then surface edge count plus equals 1. And we're going to do linear interpolation here. Okay, so we're going to lerp PA and PB by the absolute value of sample A divided by absolute value of sample A plus sample B. Is that right? Not defined between these types. Oh yeah, not PA. I need sample A. And B. There we go. Wait. Yeah, that's right. Yep. Okay, and then if surface edge count is 0, return the center point. So this would just be coords plus 0.5. Except we can't do that because it's got to be a... yeah, interesting. I'm going to abuse the hell out of this function now. It's really nice. Wish I knew about it sooner. Total divided by surface edge count. This is going to have to be converted to an F32, I think. Oh. Crap, I put this all in the loop. So the loop is actually ending here. There we go. Okay. Alright, so we're not actually calling this function anywhere. Get surface position, we should probably do that. Now, right now, our surface position is always in the middle. Okay. Let's see here. Yeah, I don't see where he actually calls this. I guess you would call this for each vertex, would you? That doesn't really make sense. You'd call it for each... Oh, he actually did say bottom left. Something like that, right? Okay, so I'm going to try calling this function with the coordinates and the sample field. You know, I kind of like the way we were doing it before. But basically it would be here, I guess. Get surface position, coordinates, and sample field. This returns a vec3. And then... Actually, I will just do it as well as all of this other work. Actually, you know what? I'm just going to do it in a new loop down here. For x in 0 less than chunk width. I should have done chunk width, height, and depth rather than 16, but it is what it is. Alright, so y, z, and I'm actually gonna just delete the surface nets vertices, which I know is a bit counterproductive right now, but that's alright. So I will just say clear surface nets vertices and append. See, I don't know if this is gonna work. This doesn't seem correct to me. This does not seem correct. Let me read the description up here. So we need to identify all the surface points and how they relate to each other. So the thing is, this function gives us back just one vertex, one position. Does that mean we only have one vertex per 8 samples, which is possible? See, I would have done this differently. Maybe I'll implement my own thing after this. Let's see. Get surface position. So I'm just going to append to the surface nets vertices. Well, cos equals p, and no normal for right now. I guess the normals will just be black or something. Or I could do x, y, z. maybe do f32 divided by 16 or something. Alright, what does that look like? Looks like crashing. Okay, index 4096 is out of the range 0 to 496. That's fair. Line 1783. Right. That makes sense because I'm iterating over 15. This needs to be -1. Alright, yeah, that's definitely not what I wanted. Interesting. So what I was thinking that we were going to do is, let's say this is our quad. That we've drawn. I was thinking what we would do is we would check, because the quads are all in between the values. So let's say this one is like 0.2, and then this one here is 0.1, and then this one is 0.8, and this one is 0.7, something like this. If this was a flat, I guess if it was flat it wouldn't. No, actually that doesn't make sense. Hang on, let me draw a 3D version. Let me think about this. So you got one voxel, and then not voxels, whatever. One value here, one value here. And one of them is negative, one of them is positive. So we drew a quad. But we might want to draw... Oh, I see what they're doing, I think. So if we extend this to having a few more... That's like the wrong place. I'm going to extend it this way. So let's say this is more values. Then we'd have values this way. And over here. And there would be one here, right? In 3D space. If there's one value here, one value here. Quad between them. Then there would be another value here, and another value here, and here, and here. I'll make them a different color. Oh, that's a bit confusing. I think my perspective is a bit off there. So those two are neighbors. Okay. But if there were two values here and here, then there would be another quad like this, right? But we never see that pattern. Because the way they get drawn, oh, that's not correct. I need to get rid of this for a second. So they get drawn correctly on the edges. Okay, so the distance between these is 1, but the offset is 0.5, if that makes sense, from the center. But maybe I need to stop thinking about it like that because they're not actually in the center of these blocks. They're in the bottom left corner. Right? When we construct this, the p-value that we... Where's the p-value come from? Here. It's just an x, y, and a z. Then we add a half coordinate on each axis. Just kind of interesting how we get aligned meshes. That doesn't actually make sense, does it? Because 0, 0, 0 is like the bottom corner, which you can't see. Actually, I'll make a white box there. Where are the debug shapes? There we go. Debug shape. Is there white? Is that a color? No. I'll put a yellow box at 0, 0, 0, which would be the bottom left, or the bottom corner is at 0, 0, 0. It's right here, right? That's 0, 0, 0. Okay. So then, if we think about how these shapes are being constructed, if we go up, there's a value that's below 0, like -1 or something. And then in front of it, on the z-axis, there's a value that's above. And so, except above this is actually here. It's this corner, and then this corner, and then this corner. So how are we getting meshes in this position? Surface knows vertices. Let me have a look at the shader. Okay, we just use the position. And they normalize the normal. That's it. And if we look in render doc, what do we get in the buffers? So my concern is that it looks good, but it should be broken, which is why I think there's a bug. Why could I not see any vertices? Wrong thing. This one? Yeah. Okay. Can we... I want arc ball. Yeah, there we go. Can I move? Well. Anyway, okay. Right. Oh, I'm totally incorrect about my debug shapes, I guess. Everything is actually aligned to the center. Okay. Right. So you can see that little gizmo. I don't know if it'll come through on YouTube or Twitch because it's really small. But there's a little gizmo here. That's actually 0, 0, 0. So actually, everything is like off by 0.5 units, according to what I was thinking in my head. Which means 0, 0, 0 is actually here. A little bit back from this. Okay. Oh, that makes sense now. Okay. So, does that matter? Should the center of a block be halfway between a block? I don't think it really matters, but I probably don't want that. So I'm going to pull everything back by 0.5 units in here. Is that going to work? Yeah, that's actually aligned now to the correct, or what I was expecting. Now, should we do that in the vertex shader, or should I do it in the vertex generation? Probably in the generation, right? So actually, when we get this position, we should just subtract 0.5 from it to get the correct point, which is the sort of the bottom left, if you think about it. Actually, yeah. So right is positive on the x-axis. Z is negative on the x-axis, though. I think. Or did I change my... I think I might have changed it. Yeah, okay. So Z's going that way. X is going that way. How long have I been working on this engine? Not long. Golden Lion, maybe a couple of hours a day for a couple of weeks. Most of it's on stream. And we changed from... I think we went through OpenGL, SDL3, and finally Vulkan. I'm planning to participate in Carl's upcoming game jam. No, I thought he already finished the game jam. Or was that his previous one? He's got a 7-day jam coming out, okay. Right. Probably not. I don't have time to do a 7-day jam. I would love to do game jams. Maybe next year I'll have enough time. We'll see. So debug shape thing, I think I will do that in the vertex shader though. I could just work on it part-time, not all 7 days. Yeah, I don't have any time part-time. Like my calendar is totally full. I get maybe 30 minutes to 1 hour per day of time that I could spend on either it or, you know, like cleaning my house or relaxing or something. You prefer 2-day jams? Yeah, I think you can prepare or plan a little bit better for a 2-day jam. Like, if I really wanted to do game jams, you know, I could ask someone to take care of my daughter for a weekend or something. My software engineer full time? No. No, I am a content creator, I guess. I don't really know. Entrepreneur. Yeah, I think that would be good. Yeah, I used to work in web. What? Oh, I think I only offset one of them. One of the cases here. Wait, what? No, that should work. Return. Oh, I didn't recompile this shader. That's the problem. There we go. That looks good. Yeah. Alright, so next step is I guess these surface points. So I was thinking, now that this makes sense again, selling courses on my site primarily, yes, that is currently my sole income, aside from YouTube, which is very meager at the moment. Yeah, it wasn't really until the last couple of weeks that I could have even had a job, because I have a daughter who's just turned 2, so I couldn't work full-time, and you can't really get tech jobs part-time as far as I know. I did apply for a bunch of part-time jobs, but no one really wanted to hire me because, I don't know, I guess I wasn't enthusiastic. Like, they would ask me what attracted you to our company, and I would say, well, you have a part-time, job you need filled, and I need a part-time job. And they apparently didn't like that. So yeah. What am I doing? Drawing points. There is also the problem of the massive amount of tech layoffs, which has probably flooded the market with a bunch of people looking for work that haven't had multiple year gaps in their careers. So that could be a bit of a problem. Alright, yeah, so. Have I released any Steam games? No, I released a game on Android, but it got deleted because I didn't update my Google Play details or something. I don't know. They sent me a bunch of emails that I didn't read, and then they deleted it. You've been trying indie dev after getting laid off a year ago? Man, sorry to hear that. It's pretty tough right now. What are you working on? What is wrong with me? Why can't I draw diagrams? Okay, let's go. Come on. You got this. Just draw the points in the right spot. Yeah, okay, this is sort of what I was thinking. Alright, so we got... Maybe you should make courses. Yeah, I mean, if you like teaching, and if you have something that you think people are interested in buying, it can work. It's not easy. It's definitely not easy. I think it's actually going to get much harder. Not that I'm trying to discourage you, but until recently, you could get away with if you really wanted to, you could sell a lot of surface level knowledge stuff and just package it up for people. But now they can just go to like ChatGPT and Claude and just get Claude to write them all the surface level knowledge stuff. You got a game on Steam that kind of flopped. That sucks. What is it? Trying to figure out what you should pursue. Yeah, the eternal struggle. I will say that building this course so far has been really rewarding. Decipher the deck. Okay, I'm gonna pull it up. I have a feeling it's not going to be my kind of game, and I am correct because it has cards in it, and I don't like cards. But that doesn't really mean anything. Alright. Think with games, huh? What did you make this with? Pretty smooth animations. I don't understand what's happening. It looks kind of like Triple Triad from Final Fantasy VIII. Made it with Godot. Oh yeah, it's a puzzle game with the theme of cards. Right, gotcha. Okay. Well, I'm biased because I don't like cards. So when I see cards, my brain is just like, nah. But that being said, I don't really know. I can't really judge it. Like, even that game, what's that really popular game that came out? That's like poker or something. I can't remember. I think it won game of the year. Balatro, that's the one. Even that game, I look at it and my brain is just like, no, not interested. It's got cards in it. Yeah. Well, okay, right. So it's a rule discovery game. Interesting. That's why I couldn't really understand. Yeah, that seems like a hard sell to me. It's a cool idea. I think this would be really niche for people who want to discover how to play something. Usually they want to be told how to play something. Second game is called You Are the Code. Alright, let's have a look. Alright. Okay. So doing some kind of assembly? Well, sort of. Storing something in a register. Or is that a variable? That's a variable. And then output. Okay, I don't really... Are you supposed to choose the order? What's happening here? I don't have sound, so... I'm not sure if there is sound. It looks cool. This looks like it might do well. If I could understand what's happening though, that would help. Like, what is the goal? What does that mean? 5544. Are you supposed to produce 5544 in the output? Actually, let me read this. Bugs are eating away at your code. You can't type. Navigate and run pre-existing lines of code. Okay. So you got to choose which lines to run in which order. Is that what this is? I thought that's what was happening, but I wasn't sure. Just to be clear. Oh, I see. And it's literally deleting lines of your code. I haven't played TIS 100, though I do own it. Dandy. think I own almost all those Actronic games. But I pretty much only played the Alchemy one. Magnum Opus or Opus Magnum? I can't remember which order it is. Opus Magnum, I think. Yeah. Alright, so let's have a look at this. Again, I should really get back to this. So, currently we've got quads like this between the 2 points. However, you got ADHD, so you give up on games as soon as the mysteries are solved, even if you haven't executed the actions required to beat it. I have a friend like that. He'll play a game for a couple of hours until he sort of understands the mechanics, and then that's it. And he moves on to the next thing. I'm the total opposite. I will play one game for thousands of hours if I like it. Although I don't play games anymore, unfortunately. I would like to. Let's see. Boom, 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 boom. I'm working on surface nets. So surface nets is a terrain. Well, you don't have to use it for terrain, but it's sort of like an ISO surface mesh generation thing. So right now we got this generating with surface nets, which is sort of like a hull algorithm. So we got values that are less than 0 on the inside, values that are greater than 0 on the outside. That's how we generated this. But I want to make it smoother. So let's see. If well, I guess. How is it different from marching cubes? Well, it's just a different algorithm. So it produces different results. I thought there was more examples on this page. There's one here. It's apparently much easier to implement. Although I'm having a little bit of a problem with this interpolation part. Let's have a look at what this tutorial says. Actually, I'll show you a screenshot first. I think you can get much smoother results than marching cubes. There's not 256 preset values. Seems like it makes meshes with more similarly sized triangles. Yeah, that could be. Honestly, although people said it's easier, I'm having a little bit of a struggle with this particular part. So what are they saying here? Alright, so we've got a sign distance field. Right. Each cube in the grid, we need to determine where we would find an ISO. So we're finding an ISO surface, if there is one. Yeah. Where the corners don't all have the same sign. Okay. Technically, we only know the distance from a corner to the closest point. We can't have enough information about our finite grid to calculate the exact intersection, but if we make the assumption that the surface is approximately flat in the neighborhood of the intersection, okay. Well, it looks like the internet died for a second. Yeah, I think it's back now. Yeah, sometimes my internet turns off. Pretty annoying. Okay, so we're going to use the similarity of triangles. See, this explanation seems more confusing than the other one to me. What is a cube edge in this case? Is it the entire edge between... What's the cube? Okay. Okay, gotcha. Right. Yeah, I think I understand. Okay, so this is basically the same as marching cubes. So why is it easier to implement? Let's see. For each axis, get a cube edge. Get a quad orthogonal to the axis. If the edges, insert the quad. Okay, yeah. Right, so I've already done this part. There can be up to 3 quads around for surface point 1. Uh-huh. At least in my implementation. I look in the negative directions from P1 to get the other quad corners. Be careful on boundaries. Yeah, okay. I'm just going to look at the implementation, I think. What language is this? Rust. Okay, that's fine. I think. Oh, okay, let's have a look. So it's got assigned. What is that? A trait? What is this where? No, that's not a trait. Okay, estimate surface. Make all quads. Estimate surface does what? Considering grid line cube where P is the minimal corner, so that would be, yeah, bottom left is what I keep calling it. Maybe I should call it minimal corner. That makes more sense. For each cube edge, because actually it's bottom right in my... Oh no, it's bottom left. Anyway, surface point is the average. Right, okay. Assign distance value at each corner. And then get the centroid of the edge intersections. Then push the centroid into positions. So you really just use a centroid, huh? That means less triangles overall, I guess. For each dimension there are 4 cube edges. This will do bilinear interpolation between the differences along those edges based on the position of the surface. Uh-huh. Okay. Alright, I think... Okay, I need this last part, which is... What do we do with these centroids? So let me see. Estimate surface in cube. If... What do you mean if estimate surface in cube? What does this return? A boolean. Okay. Now it is an out parameter. Alright. Okay, so if we did get a surface in the cube, then output into stride to index. Okay. Surface points, push. Okay, so we're generating something called surface points. And then what do we do with those? For each surface point. Okay, so this is making an iterator from the surface points, zipping it with the surface strides iterator. Okay. And then what the hell is this? CFG feature equals eval max plane. I don't have any idea what that means. Right. Do edges parallel with each axis and maybe make a quad. Huh. So it's all quads? That's a bit different. That's different to marching cubes for sure. I'm just trying to get my head around this. So let's say instead of this quad, which is what we've got right now, we make a centroid in this. Actually, I'll change this a little bit. So let's say this is another value. So it would be sort of on the front here somewhere. Maybe here or something. So that would be the centroid. But then we'd need another one, right? Which would be the next one over. God, this is horrible drawing. Okay, and then this centroid might be, I'll make it a different color. Actually, I'll make them both red. So maybe up there, let's say. So that would give us 2 points. But at what point do we make a quad? It says maybe make quad based on some condition. So if the edges are parallel with the, if y is not equal to the min y and z is not equal to the min z, and whatever this means, or x is not equal to the max x minus 1. And then they make a quad. Let's see this function. Okay, let's see. Construct a quad in the dual graph of the SDF lattice. The surface point S was found somewhere inside the cube with minimal corner P1. Gotcha. Now we want to find a quad between P1 and P2 where S is the... Yeah, S is a corner of the quad. If A is of the 3 grid axes, the axis between P1 and 2, then we must find the other 3 corners by moving along the 2 axes. Those are orthogonal to A in the negative directions. Okay, so... Alright, I see. In the negative directions. If A is of the axis between P1 and P2, in the negative directions. Why negative directions? Well, that's kind of what I was expecting. So basically we need 4. If I understand this correctly, we need not even 4. Actually, it would be... Get out of here, damn bots. Honestly. You'd think one of the richest companies in the world would be able to get rid of bots, huh? They should just make Twitch require ID. Nah, that's that's dystopian a little bit. It's funny though, I don't get bots on YouTube. Maybe it's just not worth the money. That's a horrible drawing. Let's see. We don't need that many anyway. Let's just do this. Okay. Something like that. And we need them on top as well. I should have just used those. Do I have any 3D cubes sitting around? Not really. Twitch chatters act as degenerate as bots in most of the popular channels. There are a lot of bots on YouTube, but they focus on popular channels, especially financial ones. Oh yeah, that's true actually. I was watching a lot of trading stuff recently, and anything financial, it's just totally full of bots. Tell you what, if you want to make money on YouTube, make a finance channel. The CPM, is it CPM or the RPM? Whatever, how much money you make per watch is like 10 times higher than tech channels. Which is really crazy. Anyway, this drawing sucks, but hopefully you can get the point. It's kind of hard to see now though. So we've got gonna have these points inside each one, but do we connect these points? These don't become vertices. So if I read this correctly, it says the surface point S was somewhere inside the minimal corner. I want to find the quad where S is a corner of the quad. We must find the other 3 quad corners by moving along the other 2 axes. Those orthogonal to A. Yep. In the negative directions. The axes B and C. So let's pretend we found this one and we want to move orthogonal to A. So that would be up and to the left. In this case, that's not a quad. That's a weird shape. I mean, I guess 1, 2, 3. It is a quad. I don't think that's right though, is it? So moving along the other 2 axes, orthogonal to A. S, P1, P2. Right. I feel like I'm being stupid again. Shouldn't be so hard. So up here, down here, of course it's really hard to tell what the hell these mean because there's no perspective here. But we would also have up here we'd have something, and over there, and over there. Downside of quads is it's way easier to accidentally generate them such that the two triangles are not coplanar, and then you have really nasty rendering issues. Yeah. So what I would have expected is, let's say this is P1, this is P2. If we have a look at this, and then the back left corner, this one, is our quad, our voxel. So it's this point here. So this point is supposed to be the corner of a quad in between these. So we'd go like this, I guess. Except we don't ever use that axis to the left. I'm a bit confused about this explanation here. Because it's supposed to move along the other two axes. So, oh, actually that is the other two axes. I'm stupid. Yeah, you're right. It is a mess. I apologize for that. But basically, this axis is P1 and P2. This, back towards the camera, is Z. This is Y. So actually, this is correct. Okay. So basically, we want to go... Like, why do we have to go backwards, though? I don't get that part. We could just go forwards, couldn't we? I don't really understand that point. So let's have a look. Let's model this one here. P1, P2. So that we're looking at this one. So long as I remember what it means, that's all that matters for the purposes of learning in the moment. Yeah. Definitely. So P1, P2 axis is X. Great. And that means we're going to move along this axis, which is Z. And then we're going to move up. And there's too many dots in here, I think. Like, what the hell? Let's just get rid of that one. We're going to move up. Actually, that's also... Okay, and then back. So that's our plane that we've just found. That's cool. There is a bit of an issue with this though, which is, oh no, we can just calculate the neighbors in our chunk, and we can pretend that we've got one back there as well. So that would bring this back out here. Let's just say something like this. Okay. I think that should be fine. Okay, let's try this. God. Where were we? Here. Alright, so I'm going to clear the surface nets. And here we're going to do get surface net position. So this is, no, this is not, we're not ready to do that yet. We need to get 4 points. But the thing is, we only need to do it on boundaries, which is... Okay. First thing we need to do is calculate the centroid. Okay, so maybe we should do that first. I'm just going to make another array for it. And I can clean this up later. It's fine. This would be a vec3. Yeah, whatever, that's fine. And the centroids are going to be... What's wrong with this? Oh, I need to give it a number. I'm just going to make it dynamic. And append to it. That'll be fine. So I need to get the centroids. Actually, we already know how many we need. It's going to be 15 by 15. chunk underscore width, whatever. 15 by 15 by 15. Okay, we're going to rewrite this anyway. Now, for each chunk with -1, so this is where we're going to put it. We're going to say centroid equals, I don't know, I'm just going to say get centroid based on x, y, z, and the sample field. Okay, now it might be the midpoint, which it would be for a lot of them. But the thing is, do we want... No, we'll make this dynamic actually. This makes it easier to write right now. But do we want a centroid if there's no negative and positive difference? Maybe we don't, because we're not going to use it. So, like P1 and P2 are different signs, therefore we generate a centroid, but they could also be... Let me see what this guy does. Centroid of edge intersections, yep. If there's no crossings, return false. Otherwise, return true, and also push into the centroid, into the positions. Okay. I suppose we could do that. Only if it's okay. But then we don't know what this is referring to. It's just a vec3. Alright, I'm just going to do it the dumb way first. So we're just going to always append it. Okay, I need to make a function, get, I'm just going to copy this. Centroid, the centroid is going to be... Actually, that's basically what this function is for. This already does that. This already does exactly what I'm about to do. Yeah, okay, so I don't need to write this function because we already wrote it. It's called get surface position, okay. Okay, I want to have a look at these now. Which means I need to find F10. What line was it? 1757. Let's see if there's a command to go to line. Go to line. 1757. Nice. Okay, let's run until there. Have a look at them. Or not. I think I might need to go to the next. I'm in the scope of the function now. I need to get out of here. Go to this line. Okay, thank you. Yep. So we've got 3,375 centroids. Hmm. Three, 2, 5, 5, 1.5, 5, 5, 2.5. Yeah, so these ones are, I believe, completely inside something. I think basically anything with a non-set, like with a set that isn't ending in exactly 0.5, 0.5, 0.5 is going to be on the boundary of something. Cool, okay. We generated all the centroids, and then don't care about the normals right now. We need to basically go through again. And I'll worry about optimization later. I just want to get this working somewhat. So we're going to go through again. We're going to check each set of 8 positions and see if they have crossings, I guess. And then generate... Oh no, actually I don't need to do that. I need to go... Well, if I think about it like this, check for... it's not crossing, is it not the right word? Sign difference between each point in positive direction. I guess I can do that. So I'd say like if... Actually I did the same thing up here. Here it is. Basically this. I reckon I could just do it here. Because we're already doing all the code that we need right here. So we can actually generate the centroid here. Generate the neighboring ones. It's alright, I'll copy it down there anyway. Okay, so where was I? I need this. I'm having a brain fart. Why? Okay. The value. Here's the value. We need an adjacent value. Let's say the one on the x-axis. +1. So we're just going to do this. We're going to grab x +1, y, z. Okay. And then we're going to check. Alright, stream dropped out again. Should be back hopefully. I've got 30 minutes left, so let's see if we can get something happening here. So we're just going to go along the x-axis right now. We're going to check, okay, if we found a different sign, then we're going to check the y-axis and the z-axis. See if we can construct a quad. So we're going to have to check the centroids. So we got the centroid, I guess 1 is going to be centroids. I suppose it'll have the same index. X, Y, Z. Then we want... Oh, actually, we should probably check first. So if... Oh, we already did check. Okay, so C2 is going to be... Maybe I shouldn't name them C1 and C2. Maybe I should name them C... I gotta look at the diagram. So this is the one we currently have, C1. Okay, we're going to check up the z-axis. So CZ, CZY, and then CY maybe? So C, CZ, CZ, Y, and CY. So we go, this one's up the z-axis, y, z +1. I'm just going to copy this line. This is z plus 1 and y plus 1. This is just y plus 1. Okay. So that should give us a quad, but because of the way the algorithm is supposed to work, we're supposed to check. I think we're supposed to check if these centroids are valid or something. Well, let's just see what that does. So we've got our centroids, which I guess we can just use as points. So I'm actually just going to append to the surface nets. I'll grab the x-axis ones. Something like this. Let's see what this gives us. Of course, these are not P1, P2, and P3. We've got, well, let's have a look. C, Y, Z, and CZ, I guess. And then C, CY, and CYZ. Okay. Oh, I called it CZY. That's weird. Is it? Yeah, that's weird. Well, what does that do? Let's see. That gives us an error because, well, this doesn't exist apparently. Huh. I didn't store that, so what's the x and the y and the z value here? X, y, z. What's the problem with this? Z plus 1? We're only on 12. What is 15.3375? Yeah, that's what I thought. 3375. Oh. We can't use that. That index from chords is wrong. This is assuming that we have 16 by 16 by 16, whereas we have a 15 by 15 by 15. That's really annoying. I'm gonna do something gross. Or, actually, you know what I could do? I could just append an empty value at the end of each of these. Wait, it would have to be... Oh no, I can't do it like that. If x equal to 15 or y is equal to 15 or z equal to 15, then I'm going to just append an empty value. This is really hacky. It will not remain this way. Alright. Interesting. Okay. Alright, we maybe got something going on here. I'll have to generate a few more things. These look very flat. Is that normal? Oh, that is definitely wrong. Whoa. Is that because I'm... I guess because I added these empty values, so that was actually not the best idea. Alright, I won't do that. God damn it. Excuse my cursing. I shall change these. So I'll return chords dot x plus chords dot y times 15 plus chords dot z times 15 times 15. Yeah. That only took me a second. I don't know why I didn't do that before. We got an error there. What's the error? Huh. What? Okay. Oh, of course, we can't. Yeah, the chunk height needs to be -2, I guess. Alright, now we got the same result, but we don't have those weird glitchy pieces. Okay. I just wanted to make sure it was the same, because it could have been incorrect. This is looking promising, this part here. So let's see if we add some other crossings. I don't know why I'm calling them crossings. But if we basically grab this, put it here, and we check the Y direction. And then we do... That's correct, but we want to go along the other two axes, so it would be Z, CX, Z, and CX. Okay, now these are going to be different, and I want to visualize this. So we're going... This needs to be Y. This is going to be Y, X, and Y. So this is P2 now, which means we're going to be going this way. So we've got C, C, Z, CX, Z, CX. All right, and then if we want to go clockwise, we go C, CX, Z, CX. I've got to get the, got to grab the correct thing here. So we're going on the Y-axis. We're going to grab this, I guess. Okay, and we're gonna go... Oh, this is annoying me now. Let's just make this a new line, make this a new line. Alright, so we're gonna go C, CXZ, and CX. And then for the other one, we're gonna go C, and then C, Z. CXZ. Yeah. Okay. Does that give us more stuff? Yes. Ooh, looking good. Looking very incorrect, but that's okay. The normals are backwards. That's probably the problem. Let's change all these to... I think that's the problem. Or is the winding order backwards? Okay. Well... How did I get the winding order wrong? Because... Y is up now. Maybe that's why. Let's see. CX, CXZ, and C. So we're just going to swap these. Okay, that looks good. Huh. Okay, we definitely got some stuff wrong. And by we, I mean I, of course. You guys had nothing to do with it. But let's fill in a little bit more and see how it goes. It's looking very blocky here, which may be okay. Over here is looking okay. Alright, let's do the Z-axis now. Plus 1. Okay, and we want to do C, CY, CXY, and CX. Okay. Good. I need to add this into that if statement. There we go. So we're gonna grab again these, put them on a new line. It's a little bit hard to get all the way over there. All right. Well, I will just copy the x-axis, except obviously a little bit different. C, CY, CXY, CX, and C, CY, and CXY. Is that the correct way? No, I don't think so. What did I do? That is most certainly incorrect. Okay, that's kind of lining up, but not really. And also, yeah. What the? Did I mess this up? Doing the Z-axis. Okay. Well, maybe I should have just gone with the diagram again. Let's delete all this stuff here. So Z-axis is this way. P2 is there. Therefore, we need to generate using these. I think that's the... I can't remember which one is which. But basically like this. So this would be C. And if we want to go clockwise, I guess, CY, C, Y, Z, C. Oh no, we can't do Z. This is X. Do X, C, X. Yeah, it's actually going this way. It's just that that point is up a little bit. C, CY, CXY, CX. Correct. Okay, so let's see. CX, CXY, C, CX, CXY, C. So that's backwards. But the other way didn't work. C, CY, CYX. Okay. All right. Well, I'm quite sure that the terrain didn't look that shape. Okay, what if I don't clear these and we just add more? We can sort of see them overlapping. Yeah, that's interesting, isn't it? That is a completely incorrect shape. It looks like it's rotated and inverted. Alright. So, what's the problem here? Is that why? Let me read this description again. Where was it? Here. Surface point is found. You define the chord between P1 and P2, where S is the corner. Very well. Okay, must find the other three corners by moving along the other two axes in the negative directions. I don't think that's going to fix anything here, but I will try it. But basically, we'd want to change all of these to -1. Okay. However, that's going to give us a problem, because we're going to be moving into negative space, which we can't. I mean, not negative space, but into the other chunk, right? So I suppose we could say from oh, that's going to be an issue. If we start the array at 1, then we're going to skip all of the first points. I guess I could just do that anyway and just not care about it right now. Because it'll just skip one section, but we'll be able to see the results of the other ones. And the results are very strange. I've definitely done something weird here. So the centroids, we're adding just 15 per axis, right? That makes sense. We're getting the surface position though. And sample the field with index from chords, that's fine. Okay. However, when we... Is this function wrong? Did I mess this up? I don't think so. That's the same as this. This is multiplied by 16. This is multiplied by 256. Okay, well, that's not great. I'm going to get rid of the x-axis and the y-axis, so I'm going to focus on only the z-axis. Just so there's less to change. So z is that way. That's a very weird result. However, when I say the z-axis, I guess what we're actually doing, that's the z-axis, so we're actually building quads that face, yeah, they face along the z-axis, yeah. Which means this output cannot be correct. These quads should be facing that way. So something in my code is very wrong. Maybe I should visualize these centroids somehow. I could try. I'll make them outside of this scope here. I'll just put them up here at the top. Delete this later when I remember to. And then debug shape. Debug underscore. Oh. Cube. Dot cube. There we go. So I'm going to say for centroid in centroids. Apparently that's not even a variable. It is though, right? Good. Okay. We're going to say this would just be 3. Okay, I'm going to make them yellow cubes for now. I just want to see what that looks like. It should just probably fill up the whole thing with yellow cubes. Alright. I think we ran out of debug shapes. Let's say there's going to be 10,000 debug shapes Is that fine? Apparently so. Okay, so the whole thing's just full of these, which is not what we really wanted. Okay, the next step is go to the debug shader. It's the vertex shader, I think. And basically, I want to make a scale function here. Scale cube, I guess. Actually, do I need to do that? I sort of started implementing this already. So we're gonna have scale bits. So scale is gonna be I suppose it can just be a... I don't really want it to be a U8 though. I want smaller scales. Bah. My debug shape drawing is not good enough yet. Kind of want to float, but then I got to reinterpret it rather than casting it. And it's got to fit into a... Huh. That's not going to fit. These are all U8s packed into a single float 32. So I suppose I could do a non-linear scale. That's a bit weird though. Or you could do something like scales from let's say 0 to 9 is like 1 to, well, like 0 0.1, 0 0.2, 0 0.3, and then after that it's a scalar. That's a bit strange, like a linear thing. I don't like this either. Okay, you know what? I'm not going to do this right now. I am going to comment this out. I'm going to say if centroid, I don't need a parentheses there, dot x how do I get the point value? Maybe we can do it like this. Round so round the values and subtract that from this and make sure it's not equal to 1.5. That seems a bit weird, but it might work. I'm not allowed to do that. What's the problem? That's not a function. Okay, we gotta use lin out. Oh, what happened? Whoa, round. What's the problem with this? Okay. Damn, doesn't work. There are gaps. Why does that not work? So x plus y plus z minus the rounded value of these. I suppose I could have just added them and rounded the whole thing. No. Oh, they're being rounded, not... I just want to floor them. I don't know if it's going up. Yeah, that's better. Okay. Interesting. So, we can kind of see in this first position here, the centroid is this bottom left corner. And then the second one is up there. And then over. That's a bit hard to see with all this stuff in here. But I think the centroids are being calculated correctly if I look at the positions here. It looks good. You can see it's mostly hugging around the terrain that we've got, and that should be totally fine. Of course, just temporarily I could do something like, to make it a little bit easier to see what is going on here. Basically turn all these 1.0s into a 0.1. There we go. Now we've got the centroids all showing up as these yellow, little tiny yellow cubes. And we can sort of see, besides that one's not one. So you can see we've got one there, 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 and there. Which would make this sort of shape that's pulling back, which is what I would have expected instead of a straight corner here. So these look good, actually. Centroids look good. They're all being calculated correctly, I'm pretty sure. So you can kind of imagine what the terrain's going to look like just from this. Actually, if I make these even smaller, like 0, 2 maybe, I think that might be a little bit better. Yeah. And we could even turn off or turn on depth testing. Yeah. Okay, so like over here, instead of being a flat ceiling, it's going to sort of slope down and then around, and then it'll go inside and then come back out inside this part here. Okay, I think that looks pretty good. Now we just need to connect these things up, huh? But I'm out of time, so I'm going to have to do that tomorrow. No, not tomorrow. I'm going to have to do that on Sunday. Unless I get some time in between now and then, but we'll see. So I want to thank you guys for tuning in, and I'll see you next time.